Okay, let me make sure. Okay, cool. So we're going to start with stacks. So we're moving up the wall in our little training. So a stack is just basically where two units come together. And so there's literally a gap between the two units. So in this case, this is our detail for captured stack. So really, when we say captured, it's really the sill of the unit above that's captured. This is the head of the unit below, and this is almost always in Viso, so to speak. So you never, or I would say not never, but very rarely would have this bottom portion as captured, because usually that's not the look that customers want. And we've done it, I think, on an LA job, but it's rare, very rare. So when we say captured stack, we're not referring to this head member, we're referring to this sill member. So that's a little confusing, but that's the way people talk and how you'll hear people talk about a captured stack. This is what they're talking about. So this is the sill of the unit above, and then this is the head of the unit below. So as we were working our way up from the sills, or our training of the sills, the typical sill is wind loaded down at the bottom. So our typical anchor for at the top of a unit is a dead load. So dead load just means all the weight is being held up by this bolt here. Now this bolt is the big 9-inch wide bolt. And so sometimes some people refer to that as the hanger bolt or the monkey bar. So you may have heard those terms before, but that's what they're referring to, is the same thing. Because literally the unit, like a monkey bar, you're hanging on a bar. That's literally what our units are doing. They're hanging on this one bar. So those are the terms I hear a lot. So just in case you weren't sure, that it is referring to the same object. So this one unit, which is this portion, is literally hanging from the top. And then that means this is a dead load. And that means the sill below has to be a wind load. And then in this particular case, this line represents the bottom of the vertical on this upper unit. And because of all this notching, we know that this is a wind load. So that means, again, this unit above should also have this same dead load type of anchor above it as well, because literally it's hanging here. We're allowing it to move. So in this case, like similar to the sills, this whole thing is designed to move down, in this case, 3/4 of an inch without interference. So if I just visually move that down 3/4, there shouldn't be any hitting of metal. And so that's why the notch is the way it is, see, so that it doesn't hit this little nub. That's why we have that little extra bump. So right now you can see the line of that notch of vertical. So if in the extreme, the worst case scenario, the unit moved down the full 3/4, nothing will hit. And so that's the intention. Gaskets are allowed to squish and give. Sealant is allowed to tear and rip, but metal to metal is not really allowed to hit, or glass is not allowed to break. Usually those are the criteria of our design. So that's why we have these particular notches, and these gaps have to match. So if your job has a bigger or a different gap here, you need to make sure the notches correlate to allow for that. So that's one of the things we check, and hopefully your details are shown correctly. Okay, so then let's see, stacks. So what else goes on with stacks? Okay, so we'll stick to the head for a moment. So similar to the sill track, it has splice sleeves, which are these silicone rubber sleeves that go between the unit to unit. But in addition to this front splice, only on stacks, we have this little extra splice in the back, which is called an air seal. So this is a dry area, if you recall. So it's not for water. It is literally what it's for is air. So we'll see, I'll show you in the 3D model over here on the installation manual, but it's to prevent a gust of air and a whistling sounds to come through at this spot where these splice together. Because if you remember where these splice together, there's going to be a 1/4 inch gap. And so air could just flow right through and you'll hear like a whoo, whistling sound. And so we don't want that. That would be poor quality. So the field adds this in at the stacks only. So, and that also I think is, so don't quote me on this, but I think it's also for fire safety, so that the air, if there is a fire, it helps prevent the suction of the air, the balance of the air, so that hopefully prevent the air from being sucked up and in if there were a fire faster or something like that. So, so you'll see this only at the stacks, not at the sills, because it's really only floor to floor that this is required. And then you also have all this kind of notching. So some people get confused with what that means and where that's at. So I was going to show you in our installation manual, because it's shown really nicely there, what that means. So let me get to the right sheet. Okay. So hopefully you guys can see that. And let me go up one more sheet if it can show. Oh, sorry. Oops, I lost my page. One more sheet. Oh, oh, he didn't show the fabs. Okay. Well, this is a view of the splice. So sorry, it's not showing the notch I was referring to. So sorry, let me finish showing the splice here. So this is a unit to unit splice condition, top view. So this is what the field will see. And so there's the 1/4 inch gap of your sill. And then there's the notching in the back for the bayonets. So if you recall here, this is what this line, this hidden line represents, is that bayonet. And that's actually inside the vertical. So that's why it's shown hidden. So it's actually here wrapped around this raceway. And so this is called the Bayonet Race, some people call it. And it's held in place with these 2 bolts. And then it literally is like a track that nestles the 2 units together. And so that's what we have to notch this head member to clear the bayonet. So technically we don't show that notch in this 2D details, but it does happen. So again, not very accurate there, but that's what needs to happen here to allow the bayonet to stick up like this. And then here is that silicone sleeve, that 08T in the front, and the field just pumps the whole thing with sealant. And then there in the back, you can kind of see that air seal guy in the back. Okay, so that's the splice in general there at the stack. So this notching, I apologize, I thought it was shown here clearly, is to allow this top portion of the chicken head, this top line, and this back leg to extend to the middle of the vertical like this. But yet these parts that are notched actually have to stop at the daylight. So that's what these hatches represent, that those pieces have to be cut short so that they sit flush on the side of the verticals. Let me do a quick flip. I know we have a view of that. Maybe just I picked the wrong sheet. Give me a second. This manual got too big. Yeah, I'm not going to find it quickly. Yeah, getting close. Nope, sorry. Okay, I'm not going to look for it. I'll show you here later. But do you guys have any questions on that? Okay, and then this little hidden line, it's very subtle in CAD, but that represents the top of the vertical. So again, you can't really see it, but that's really where the fab team cuts the top of this unit below. And so that's why this dimension is important for them. So in case you're wondering, that's why it's better you give them this dimension so they can measure in their fabs from top of vert to this mat clip, because that's what they put on their fabs. If I gave them the dimension to this, that wouldn't be as helpful because this piece is not connected to the vertical yet. So they wouldn't have this point to reference. So that's why the fab team wants this dimension to that point, because that's top of vert. Let's see what else is there on here. This little trim, I guess you can call it the Inviso trim. So it also has the notch. Same thing. This portion of the hatched portion has to stop at daylight or the side of the verticals, because again, you see this line is the top of vert. So it has to stop where it's going to hit that vertical. But yet this front portion needs to also extend, like we saw here, to the middle. So that's what that notch represents. So that little piece is stopping, the hatched portion is stopping on the side of the vertical, but then the front portions has to meet with a 1/4 inch gap. So that's what those notches represent. Okay. Okay, so that's that stack. So then when you go to an Inviso stack, this is the same logic applies. It's just now there's no captured face in the front. Okay, and then we have these little options over here. So sometimes you'll see details like this. So when you see it hidden like this, that means that this bolt head is now inside the vertical and not visible. So our typical bayonet bolt is visible from the side. I don't think I show it in the verticals, but it's actually shown. You can see the bolts on the sides of the mullion. Okay, and it doesn't look pretty, but usually they're hidden anyway, so it's not a big problem. But sometimes the floor anchors are visible from the inside. So you don't want to show a big bolt head from the inside of the building. So this is what we do at those cases. So this really should only be used when it's visible. This is our standard for when it's just standard, not visible anchor. And this is our standard when you have a visible anchor. And then to the notching, just like the sill, can be a wind load or a dead load. So again, for dead load, these legs will now be sitting hard onto the chicken head. So that means the vertical and all the weight of that unit is sitting here. So then if that's your case, then above your anchor should be a wind load anchor, because you can't have 2 dead loads on any unit. Every unit needs 1 wind load and 1 dead load. So that would be something you would check. So if by chance you have a dead load, you should double check that your anchor above this particular unit is a wind load, because you can't have both dead loads. Okay. One other thing, just for all of your sakes, a current standard update is this gasket. It used to be a 276. But now it's a 483, so just kind of keep your eye open for that. That's a new standard for Invisos. And that's just because the field apparently was having some issues with the other gasket. I think it was too soft or something was off with it, and they kept having problems. So the Jumpstart team made a new gasket for them. So this is the new standard. Also, another standard is this 279 gasket. It's basically a hard plastic material, this top part. And then the little wipers, these guys are a soft, squishy material. So that's why it's drawn as kind of 2 separate pieces. And then this part is literally hooked on to the setting chair. So you just have to remember this part of the gasket is continuous. It runs all the way across. But this little setting chair is only 6 inches long or 4 inches long, and it only happens 2 per unit. But in this case, we add a 3rd one. So this is, again, a newer standard. So imagine you have a big 5 foot or maybe 7 foot wide unit, and you only have 2 places where that gasket is being held in place, which is our standard. So we were seeing that in the middle, it would sag. That's 279. And so this gasket and this joint would get bigger and it would look wonky. So our improvement was to add 1 more of these clips in the center of each unit. So that way this gasket has 3 places where it's being held up. So this setting chair is serving dual purpose. It's supporting the glass, which only needs to be supported in 2 places. But then it's supporting this gasket, which needs to be supported in 3 places. So this is why our new standard is you have 6 inches long at quarter points, but then the 3-inch long at center is strictly just to help support this 279 gasket. So that's our new standard. So any Inviso gasket, not just the 279, but any need that 3rd setting chair per unit. Okay. Let's see what else we got on there. Okay, so any questions about stacks? That's pretty much it for the stacks that I could think of right now. Any questions on the stacks themselves? Any questions? Okay, cool. All right. So then we're going to get into a little bit more of the meat, which are the anchors. So first off, I also had over here, sorry, just to show you a couple of more differences or variables in stacks. Sometimes you'll see the lifting lug instead of a bayonet. So this is only used when the field has no access or limited access with the bayonets, or when the mullions don't align with each other. Like if you have offset mullions, because the bayonet, the mullions have to align, right? Because the bayonet links them together, vertical on top of vertical. But if you have a vertical here, but then a vertical off to the side, the bayonet won't work because it can't align the bayonet raceways. So you have to use a lifting lug. So that's one of the instances when a lifting lug is required. Another time that these are required, I believe, is when they have limited access, because a bayonet, as you saw in the detail, it sticks out quite a bit. So the field literally has to bring this, be able to lift this unit up and over the top of this bayonet in order to slide it down. But if they don't have room above, they're not going to be able to get that unit in. So usually at a soffit location, or if you have precast above you or some kind of stone that's already in place before we put our units in of a curtain wall, usually we have to change that top anchor to be the lifting lug. But everywhere else could be a bayonet, but just that top last unit, they have to use lifting lugs. So it's just, you have to look at the whole building. So again, this is where you have to see think of the building being installed and look at the elevations, not just details, because these details are correct, but on your particular job, you might need this in some places. So it's just a good thing to know when you need this lug so you can look out for it on your job, because the details still look correct and this will work, but it only will work in certain cases. So just have to look out for that. And then we also have false stacks. So the difference with the false stack is it's false. So it's not really 2 units coming together. It's really acting like a horizontal. So you can see the way we draw it is quite different. You don't have the lines for the notching because there is no notching. There is no gap. It is really just one vertical running through. So that's why you have the lines here. That represents the vertical. It's just running through. You don't have the splices because there is no splice. It's stopping daylight. You don't have the notches because it's stopping daylight. So it's really acting as if it were a horizontal. It's just a really big horizontal. So that's what this is, a false stack. So when you see a false stack, to me, I just treat it like it's a horizontal. And that's really the only biggest difference. It's just a big horizontal made up of a lot more parts. And so the reason we do that is just so that it looks the same when it tracks around the building. And if some case your anchoring needs to be different for some reason, usually it happens at soffits where you have a hanging unit and it's only 1 bay high. We don't make a little unit. We would just extend this unit above and make it longer, and then just put a false stack so that it matches the rest of the building. So that's usually where false stacks happen. There's a lot of other cases where it does, maybe balcony transitions and stuff, but that's really the only difference detail-wise with the false stacks. Okay, any questions on the false stacks? There's not too much, they're pretty simple. Just treat them like a horizontal. Okay, so that was stacks. So now we're gonna get a little bit more into anchors. So I'm not sure how much you're familiar with the anchors. So I'll try to go logically as my mind kind of wanders a little bit. So let me see if I show you everything. Oh, no, see, I forgot one thing. Okay, so one other thing that's hidden and you don't see it in our details at all is the end dam of a stack joint. So just like our sill tracks at the jams, we need some type of dam because otherwise water will just flow into the building. We used to try to show it in our details, but they were always wrong and very confusing to show on this already complicated and tricky details. It's a lot of lines, a lot of fasteners, sealant work, and there's a lot of stuff going on, and it's really hard to show it in a 2D detail in addition to showing everything else that's going on with a stack joint. So that's why we took them out, because most of the time too, they were drawn wrong anyways. So, so the best place to look at that end dam of what's happening is in our installation manual. So I'm hoping you guys know where the installation manual is. It's on the portal, but it's also on the S drive in the detail library. There's a folder called W75 installation, and there's PDFs and CAD files there. Okay, but I wanted to show you it so you guys can understand what it looks like. So I lost my page. Okay, so here is the end dam at a stack. Okay, so in plan view, we don't show it. So this is technically, I mean, this is technically correct in that it looks the same as our standard end dam, but in our details, if you see this end dam, we're not referring to the stack end dam. So don't get confused. We're not showing the stack end dam up at your anchor details. So in our details, when we show an end dam, we're just showing it at a sill track below at the very first unit, not at the stacks, because that gets confusing because they're different. So you can see this one is fab totally different. It has a leg going down, whereas our typical stack does not. I mean, typical end dam does not. So there's differences, and that's where usually we got it wrong. And so that's where it gets confusing and people don't understand what you're showing because they look the same from the top, but really they're not. So you can see here's the side view. All of that line work we tried to show in our details in addition to fasteners and such, because there's 2 fasteners, see, which are not shown here. So if you can imagine drawing all that on top of that stack detail that we just looked at, it's just a lot of lines and hidden lines and people didn't even know what it meant. So anyway, so this is what it looks like. And so this happens at every jam at your stacks. So again, the big thing is you can see how much, how it looks. So this is where you got to be careful of what's happening at your jam. So if your caulk joint is recessed, this is going to be exposed. That's a problem, right? If you don't have a perimeter material, sometimes we have an open jam and maybe the caulk joint is back here. You have a problem because all of this will be visible, ugly, has to be hidden. So just stuff to look out for. Again, you got to think 3-dimensionally of this kind of stuff is happening, even though we don't really show it on the details. This is what's happening. So if you have anything going on with your caulk joint here, it should be a little heads up. What's happening with my end dams? Because they're going to be all visible. And then usually our fix for that is we end up putting a cover, an additional either break shape or sometimes even an extrusion, depending on what the customer wants. And it's an additional piece that we put on to basically hide all of that, is usually what we do to accommodate that. So again, just something to be aware of. When you have a flyby, when it's has to really look pretty. So that's something, again, to look out for, what's happening at the ends, what's happening at the jams, because this usually gets overlooked because we don't show it in the details and people kind of forget about it. So it's just one of those trigger points. Just kind of remember, I have end dams at every single stack. I have an end dam at every sill track. What's happening at my jam lanes? So it's just something to be aware of. So again, the best place to see it is here in the installation manual. Okay, now I think that's it for the stacks. Okay, so now we get to anchors. So just a little terminologies we'll go over a little bit. Okay, so the hidden line is the hook lug. And that's all that I hear it being called as. I don't know if you've heard any other terminologies for a hook lug, but that's what it is. The hook lug is just referring to this hidden line, and it's actually shop applied to the units. And there's 2 per mullion. So in plan view, That's what these guys represent. This rectangle and this rectangle represent the hook lugs. So you have a left and a right because of the fabrication. So this is purposely done. We indent the holes. So that's what this notching represents here. We actually indent the holes. And so that gives this, I believe, so again, don't quote me, but I believe the reason we do that is because there's not a fastener that can drill through 1 inch of material. And also I think this gives it more strength because now you're getting more of the bearing of that fastener into the mullion rather than just going through a wind lug, the hook lug. So I believe that's why we indent them, but don't quote me on that, but I believe it's more structural reasons of why we do that indent. This head is, you're looking at the top of this fastener, the 62 AP. So again, we're looking at the top. So if you see this fastener, that means it's a dead load. Okay, so that fastener is what's pinning this unit to that monkey bar bolt. So if you look at the side view, that 62 AP, the head is sticking out, but the bottom of it is right on top of that monkey bar bolt here. So that is what's literally pinning the unit in place. So that way, if the monkey bar moves, the whole unit moves, and that monkey bar is attached to the floor. So that's where it's going to move together because you're pinning it together. Okay, so that's your little trigger point for dead load, is this guy. Okay, the other little trigger for dead load is we now have made a new hook lug just specific for wind load. So what we used to do, we used to just remove that bolt, and now it's a wind load, which is technically correct. But it got confusing, and a lot of errors were made in that regard because sometimes we would fix it only on the side detail, but then the top view still showed the bolt, or vice versa, or elevations show dead load, and the field is just used to putting dead loads, and they put dead loads in where there should have been a wind load. So the improvement was to make a separate die for the wind load case. And here I have the dynamic block for wind load. Okay, so that looks like this. And so it does not even have the hole at all for that fastener. So it's super obvious that this is a wind load now because they can't even make it a dead load if they wanted to. So that's why we created this. Also because I believe besides visual control, I think it's just made things a lot easier for everybody to have a separate part number for wind load versus dead load. So that is a W75 5709 is the new die for that. And then the new standard now apparently is that this wind load will only be 1.25 inches. So you should never have a 1-inch wind load detail. So that's another little standard that the management team made. So if you have this detail here and you change it to 1.25 inches, so that's how it should be, like that. So this is what your wind loads should all look like from top view. And you should never have the variable of the 1 inch because it shouldn't happen anymore. Okay, so this is a wind load anchor now. I just changed. So you saw though, when I moved this block, this fastener moved with it. So this is, again, I can't remember. It has a bunch of names, the screw that people call it. Some people call it the adjustment screw. Some people still call it a temp screw. It's not really a temporary. So that's almost like an index clip. If you remember what the index clip does, it's help the units from drifting left to right. So that's what this is doing. And so it kind of looks weird in plan view, but it's actually going through that little hole. So you see these three little holes of the mat clip. That fastener is this one, the 63 AP. So there's a hole in the mat clip that it's going through, and then it's just literally touching the side of this hook lug. So that's what we're trying to show here. So it has to butt up to that hook lug, otherwise it's doing nothing. So again, sometimes that's a mistake that happens. So that's why in CAD, we made it part of the dynamic block so that it moves with it, because sometimes we accidentally adjust the hook lug, but we forget to move that fastener. And then it's not there, or it accidentally gets deleted or something. So it is needed in order to kind of help lock these units in place. So that's what those guys are doing, and that's why they're shown like this. Okay, so that's the hook lugs. I believe that's all there really is to know about hook lugs. That's all that I could think of for hook lugs. Okay, so then for the anchor itself, the Mac clip. So this is the Mac clip. So again, don't get these confused. Sometimes some people get hook lug and Mac clip confused. So they are two separate things. The Mac clip is the actual anchor that connects our units to the floor slab or to the building. So the hook lugs are attached in the shop, but the Mac clips are attached out in the field. So they are two totally separate things. Even though all of our details and an AutoCAD, they're like one block, it's kind of confusing, but they always go together. But one is a field use item, one's a shop use item. So these Mac clips from the side almost always look the same. So the tricky part is that's tricky because they're not all the same. So you need to know what your views are, what your anchors are doing from both top view and side to make sure you have the right Mac clip in the right spot. So we have different Mac clips for different conditions. So let me, oh, that one's exploded already. Let's see if this will let me. Okay, so the Mac clip itself, this is the extrusion. So this is the die, that's the actual shape that gets extruded. And then we order these prefabbed. So that's why they have a mark number, because we order these from a vendor and we tell them, I need 2000 Mac 11s. And a Mac 11 has the certain size slot, it has a certain, the hole locations, it has a certain height. So those are 1-to-1. So if by chance your job, you need something different, that's a totally different fab. We can't just still call it a Mac 11 because it's no longer a Mac 11 anymore. So those are the kind of things we need to just look out for when, if by chance you're asked to modify or stretch your Mac clips or something, you can't. Or you can, but you have to make a brand new number. So that's what in Revit, we're making it smarter, where I have dynamic, or not dynamic blocks, parametric families made. So that way I only list out the Macs that are available. And so you can only pick from those. And so if it's not on the list, you have to ask for one to be made, because we have to make fab drawings and we have to assign a number for them. So so this one is the typical, let's say typical, where it happens at an intermediate vertical like this. And then we have, oops, that's, oh, I don't have it. That way, let's see. Nope. Okay, sorry, I thought my block was set. Okay, so I'll just modify this one. So if we need it at a jam, I think you guys have seen it, where we rip that leg off, that's actually a different die. So that's a Mac either 12 or 13. Okay, so this would be attached at a jam mullion, and then the opposite of this would be the opposite. So those are the three different standard views from the top, but yet from the side, they'll all look the same. See, so that's where it gets confusing. So technically this one detail will work for your intermediate and your jam mullions. But technically in plan view, you may have 2 or 3 different clips needed. So that's why it's important to show what you really need in plan view also at your anchors, to make sure it's clear, because some jams could use this typical one and you won't need these, but only special cases you do need these. So you have to make sure you show it in your plan view, because side view, nobody will know what you need. And then when you're doing your embed layouts, that way you get the correct one in the correct place where you need it at your particular jam conditions. And then if you're ever curious of what these are or what they look like, we have that MacClip wiki page, which has the fabs for each type we have available already made. So in case you're curious of what which number looks like what, they're going to be all there on that wiki page. Okay, so that's the standard MacClip. Again, this is the standard one, the MIS 5725. That is the most current and standard. And that one will work up to mullions that are 3 inches wide. So once you get to wider mullions, you're going to need a different mat clip because otherwise these hook lugs and such won't fit. So that's just one little trigger point. If you have wider mullions, make sure you have a new die for that mat clip. Okay, so the mat clips are attached to the embeds typically with this bolt, which is called a T bolt. So it's called a T because the back portion does look like a T. And so literally that slides in. And so like if you go on the field, you'll see all these embeds in place already in the slab. And then the field will slide these in. So just imagine like just imagine it sliding through across these raceways. They will slide two of these in. So then you'll have the bolts just sticking out. And then they'll come and put the mat clips straight on. And so the mat clips, if you recall, have this slot in it. So it has two holes in it. So then they'll line up the bolts through those holes, get them in the right spot, left to right, and then they'll tighten it down. And then that's what they'll use these washers and nuts to tighten them in place. So that's kind of the order of installation. And that's why the bolts and the nuts are on the outside. Okay, so that's how they would do that. And then we no longer weld. So we used to have the studs welded to the edge of slab when it was a steel deck edge. So we're no longer doing that. So if you do have a steel deck edge, our standard is now to use a steel mat clip instead and weld directly to the steel instead. So that's kind of our new standard. So if you ever see or somebody asks you to do a welded stud, a flag should go up. Like that's no longer as a company what we're doing anymore. And we should have taken all that out. And in Revit, I think we took it all out. In CAD, I'm not so sure. Okay, so that's for that. And any questions on the mat clip? There's not that much there, but I don't know if you have any other questions on the mat clips. And then we do have in our installation manual, these are kind of older ones, but it still shows you in 3D, nice little view, kind of like I was telling you, see how the T-bolts are put in place and just sticking out of the embed. And then the field comes and puts this straight on. And then they put the washer and the nut. So this kind of gives you a nice little visual of that. And so this is in the manual. And then here's, again, just a little visual. These are old mullions and stuff, but it shows how the mat clips are on the building and then how our units just come up and over and then in place there. So there's your kind of visual of what our mat clips are doing and how they're installed in a 2D place. So if you actually go out to the field, you can see it in real life. But that's the kind of logic. And again, it's here if you need to reference it for your visual sake here. Okay, cool. All right, so the other last thing I wanted to touch on was pony tubes. So we see these all the time. So these are called pony tubes. Some people call them anchor tubes, I think, tube anchor. But pony tube is what I hear the most. So some people may not know why I don't know why we call it a pony tube, but that's what it is. And there's a couple options for it. So this is our standard. This 2.5 by 4. That's our standard. But in some cases we have to use the thicker steel, aluminum tube. Oh, this one's exploded as well. What happened? Oh, my things are exploded. Which is just a heavier, it's thicker, and I think it's 1/4 inch thick, and it's shorter. So in case you have back pans or something here that might interfere with this, we use that shallower, stubbier pony tube. So those are the two options we have for pony tubes. So now the thing you have to look out for pony tubes is how they're attached, and then what are they possibly interfering with. So again, there's a lot of stuff going on in the detail, but the same stuff that we're using on our mullions work on the pony tube. So instead of attaching to a vertical though, now they're attaching to a tube, okay? But the caveat is a vertical runs the full height of the unit. And so it's attached down at the bottom with a wind load and has a dead load at the top. This pony tube does not. So this pony tube does not run the full height of units. it usually only fits in one bay. So it needs to be attached somehow to the unit. So that's what you're seeing here. These two angles you see on the left and the right, 1.5 by 1.5 by 3/16. That is showing how this tube is attached down below to the next horizontal member. So if you don't have a horizontal member below your anchor, you have a problem because you have nothing to attach your pony tubes to. Okay, so it's assuming it has a horizontal member to attach to. And if you don't have one at your anchor point, you have a problem, like a pony tube won't work. And that has happened on jobs. And that's where we had to introduce that new detail with the shelf. It's a horizontal shelf kind of tube to act as a horizontal. So we have to add that in order for these pony tubes to have something to sit on. So that's something to look out for because sometimes that gets missed. So I kind of tried drawing it in 3D for you. And then also just, you have to think about what's happening at the top. So how is this tube attached at the top? So that goes back to our stack joints again. And that's what this little detail is showing. So this clip is for the pony tube only. So if you have no pony tubes, you don't need this detail at all. Okay, but this line, I'll show you in 3D why we need this. This is representing the notch in the pony tube. So the top of the pony tube needs to be notched in order to clear this leg. And then the top of the pony tube is equal to the top of the vertical, which is at this point, which we determined. Okay, so, and I'll show you that in 3D here. So let me get to 3D here. Okay, so here I try to model the pony tube up to the stack joint. So here's the clips at the bottom. This blue is the pony tube. So you can see if I have no horizontal member, my tube is just floating in space. And that's what the detail is showing. I'm clipping to something, but there's nothing here. So you have to make sure there's a horizontal member for this pony tube to attach to. Okay, then at the top, what we were looking at. So I didn't show that clip because I just wanted to show you what, I just quickly modeled this. But you can see right now the back of the tube hits that back leg. And if you remember, this tube is happening somewhere in the middle of, or offset of the end of the unit. So it's not happening at the end, it's kind of in by 9 inches or so. So the shop has to notch this. So that's why it's critical. The fab team needs to know where do these pony tubes happen. So it's a critical layout for them. Because not only do they have to notch this head member in the right spot, they also have to lay out all these clippy things. So that dimension that they ask you for on your, I think it's on your elevations of where's the center line of pony tubes, it's critical for them because they literally are cutting metal at that exact location. So if it's wrong, they're going to fab it wrong. And that's your head member of your stack. So that's a big deal. So that is a super critical thing for a fab team because I can't fudge it. If by chance this notch is off even by 1/4 of an inch, that tube won't work. And your unit you can't make this, you'd have to remake this whole head piece. So that's super critical for the location of these pony tubes. So then you can see underneath 3D here, we would have that little clip right there. So I didn't get to model that, sorry about that. But there would be a clip right there. And that's what's going to attach the top of this tube to this head member. So now it's structurally in place. And again, that would need notching. So they would have, the fab team has to notch these raceways to clear this tube as well. So they have to kind of gut that whole thing out. But that's how it's attached. So that's what that detail means. So again, if you have a different head member, you need to and you have pony tubes, it's good to make sure this detail is correct for your condition. And again, sometimes that gets missed because this is just a standard detail, but this is really only for this head member. But if you have a different head member, let's say like here, this one, I have a solid head, that clip doesn't work anymore. That's actually that would be the wrong detail. So we would have to make the new detail of the clip required here, which would be different. So it's just stuff to look out for that we can't just copy and paste, right? We have to know what's happening on our job And if you don't have pony tubes, right, you don't need this. So it's just good to know how your building's being anchored and where. Okay, so any questions on pony tubes? No, pretty good. Okay. All right, so the last one, just because it's been coming up on a few jobs also, is this weird guy here. So I think we're calling this the elbow anchor. You may have heard of it, but it looks funky and is very hard to understand. So this is the top view that we have right now in 2D, which to me still looks confusing. And then you have this side view, which also is crazy confusing. So I don't know if you guys even really understand what's going on here because it's a mess. These details to me are horrible, but this is what we have. And this is what you're drawing, and this is what you're expected to understand what the heck you're showing here. But it's really confusing. So I just wanted to walk you through it as a training just to show you what they're trying to show here. So this view is literally taking a cut right here and looking this way. And they're trying to show what this rectangle looks like in the side view in relation to these bolts, okay? So they're showing that this rectangle is actually the yellow line shown here. So that rectangle is this. So it's this tall, what is it, 8 3/8, and it has this weird notch in it, right? That's what's happening with that one plate. Okay, so that's what they're trying to show there. And then here's the two bolts, this one and this one, which they're showing here. But then they get crazy by showing all these stupid hidden lines, which they're trying to show the Bayonet Raceway, which we never show that in any of our details. But why they decided to add it here to make the detail even more tricky to understand, I don't know. So I mean, I would love to get rid of all that crap, but it's there. And they're trying to do a favor and tell the fab team to notch the Bayonet Races. But that's what you would show here. Fab note, mill off Bayonet Raceway, right? So again, so it's just a weird stuff going on, but that's what they're showing. So those lines are not really necessary. Showing this note here and having those notched in this top view would be enough for the fab team. You don't need to show all this extra stuff. Again, that's just whoever drew this was getting too fancy because it just adds more confusion. Don't know what that stuff is. Okay, but that's that. So that's the yellow plate. Okay, then that plate gets welded to this L angle bracket thing. Okay, so that L angle bracket, again, is not clearly shown here at all in top view. Can't tell what the heck it is, but it's this red hidden line. How are you supposed to know that? I don't know. And in actuality, this line should be solid, because if you're looking down on it, that would be solid. All of these lines would be hidden. So that's also confusing and incorrect. So why they drew this line as hidden, but the rest solid, I don't know, but technically that's wrong. So that's confusing. So I just want to make sure you guys understood that this red line is representing that L angle steel thing. Okay, so that L angle steel, as you can see, I think that's even drawn wrong. It looks like it stopped short here. So let's see. Oh yeah, okay, good. It stopped short here. So this is that red line. So I'm gonna just change this to hidden red so we can better see what we're talking about here. It'll let me, there you go. Okay, so there's that red. Okay, so that guy is coming out at us a certain distance. Okay, so that's what this view is. So now we haven't gotten to this part yet, but right now that's what this view is. And in our 2D details, they actually call out a bubble here, looking that way to try to indicate that that's that view. Okay, then this view, they made this separate thing, okay, which is also confusing. So now they're no longer showing the stuff beyond, which is this. Now they're just focusing on what these two lines represent, okay, which again, though, is hard to tell from this side view. So these two lines are also the yellow in that view. So let me just change it to yellow. Okay, but it looks like two separate plates, but it's actually a tube. So I don't know if you could tell that. Again, can't tell from this detail, but it's actually a tube. So you don't see a tube anywhere in either one of these details. So it is super confusing. So sometimes people ask that this is a mistake because it says steel tube, but it looks like two plates. It's really a tube. So I have a 3D model of this shown in Revit, so I want to show you guys. But this stuff is super confusing. And so if by chance you're asked to draw some super crazy thing like this in 2D, you should just stop and say, I'll model it. Let me just model it. Because nobody understands this 2D stuff. It's crazy. And there's more room for error and misunderstanding. So I always vote, if you need multiple views of something, it needs to be 3D. And that's where transitions evolved from, because we try to draw everything in 2D and it's just a pain. And the fact that you need 3 views and actually 4 views to understand what's going on here, you're not going to get 4 detail cuts on your elevation to try to show this thing. So a 3D view would have been perfect to just plop in here, and then you don't need any of this extra stuff. But anyway, so that tube is represented here in these yellow lines. So you can see they kind of show these hidden lines that represents the tube, the thickness of the tube. And it has this little chamfer here. Okay, so again, you wouldn't see that anywhere else. And then you have it welded to this L shape, this red one. It was red. So then you have this little tube is acting like a pony tube. Okay, so basically that's what it is. We're creating kind of a false pony tube and have to structurally support it. Okay, so let me show you the 3D real quick. Hopefully. So this is it, but it's laying on its side because it's face-based onto the mullion. But that's what it looks like. And see, in actuality, this is not showing that chamfered notch here. That's missing it. But that's the tube. And so if you cut it, yes, it would look like 2 plates, but it's really a tube. So I just wanted to show you guys, because this is funky, but if you saw this instead of those drawings, I think that would make a lot more sense. So we do have the Revit stuff for these guys if you have them. But again, if by chance your job requires, let's say, a thicker plate or a bigger tube, it's a new fab, it's a new number. We would need to make a new model for it, all that stuff. So again, just be aware that whatever's not in the library right now, if it's something custom and you had to, somebody's asking you to stretch this or move this or even change the bolt size or something, that's a new fab. And so you would have to make sure you ask for a new number. But that's what this guy looks like. And this is the elbow anchor. And you would need a left and a right for your jams. Okay, any questions? I think that was it that I had to cover. Did you guys have any questions or anything that I didn't cover that you have questions on in relation to stacks or anchors? No, no, there's no dumb questions. So if anything you're not sure about, let me know. We do have what we call the offset one here. So that's a different number. I can just show you real quick the Maclet wiki page just in case you guys haven't seen it. Because that also has the Revit information you need to know which generic models to use as well. So glass division, Maclet standards. So here's the fabs for each one and their number. So if you need to see what a Mac 11 looks like, you can look at it here. And see, it's nice too, you get the little ISO view of it as well. And then here I tell you where we have the Revit information for 2D detailing. And then under the other wiki page for generic models is where you'll know where to get the 3D object. So if I go under Revit standards and then Revit generic model nomenclature. So here, mat clips. So here is where Oh, no, it's embeds. What was it? Not clips or generic. Oh, did I have it on here? And I just don't know. Steel Max. Oh, so I have it here. How come I didn't put it here? I have the 2D detail component. I don't know why I don't have the generic model information here. It should be here, like this one. Oops. Like this. So you have the Fab, Revit generic model, and then the Revit 2D component. So that's what it should be here. Maybe I thought I linked them here, but I didn't. But you guys know where to find them. You've been using them. I just have to put it here. So that's something for me to fix. But yeah, so all that information is here. So yeah, and if you don't see the one you need on that list, yeah, please make sure you ask for a new number so we can make the fabs and stuff for you. And that's it, I think. So let me stop the recording.